So for that, in SolidWorks also we have to select these threads. Internal threads are selected. It is matched with the external thread of this tie rod, this one, and it could be moved from on this axis. And to fix that movement on that axis, let me freeze this plane with this plane. So this is fixed. Now it cannot be moved. So this end, small end of the connecting rod is also fixed. Rotational movement is allowed. It is not restricted in this case. It also can be restricted. Now one more component, bush 1. This is called, and this bush is inserted in the small end of the connecting rod over here. So mate this surface, select this. So this surface and this surface become coplanar to each other. So they become coplanar, select, and this assembly is made. So fourth component is assembled, that is bush rod, bush end, which is inserted in the small end of the connecting rod. And these planes are parallel to each other. So it is made parallel. Big end and small end faces are made parallel to each other. It also can be rotated. Now browse the last another component, that is tie rod that we have assembled, fork 2 assembled, fork, this one. This is assembled over here, fork end. In the fork end, here hole is there, external and internal threads are there. So match these two threads. Now with matching this surface, it could be axial movement is possible. Now to restrict this axial movement, this nut is provided at this end. So call this nut and match these threads, internal thread of this nut, external thread of the bolt. Both are matched over here and they could be assembled. So assembling of this nut with this external thread is made over here. So this is assembly. Import this nut to here, from here to its place. Let me zoom that, this one. Import from there to here. It is imported. So now these two surfaces are selected and they made concentric to each other. So now they are concentrated. Concentric circles are there. Both are having same center. Now align these two surfaces. The end surface of nut and bolt are aligned. So this nut could be fitted over here like this. So this is also assembled here. So this is the assembly of connecting rod. It could be rotated. This nut can be rotated, and with the rotation of this nut, it tightens this inner surface with this inner component, making alignment parallel to this, and this surface should be parallel to this one, so that the assembly could be restricted from other movements. Click OK. So I hope the details of assembly drawing of connecting rod is clear to you. Now working detailed drawing or working drawing, or we also call this detailed drawing of an assembly. A design that has been approved for prototype or full scale manufacture requires a set of working drawings to communicate to the object's geometry to everyone involved with its manufacture and assembly. So for that, working drawing is used. Working drawings are a complete set of documents that include individual part drawings, one or more assembly drawings, and a parts list. In working drawing or detailed drawing, majority of the informations or almost all the informations are represented with the standard notations. Now features of working assembly drawings. These are the features. Only simple assemblies are drawn in this manner, as views have to be chosen to show the assembly relationship as well as sufficient dimensional details of individual components to enable their manufacture, so that it could be manufactured with anybody, any skilled person that needs to be represented in the working assembly drawing. Some more features: These drawings are suitable for furniture construction details where the assembly views are not complex and the details of joints may be enlarged and shown as partial views. Now, what is exploded view? How it is used and what's the importance, that we will see in this animation, how assembly of exploded view is used. This is one typical assembly drawing, assembly of the components. Now if we draw this assembly, then it would be difficult to understand how it is working. So here 6 nuts and bolts are there as shown over here. So we disassemble all these nuts to show like this at certain distance. It is moved at certain distance. We can insert this distance of movement. So all these 6 nuts are placed at certain distance from its reference to represent the relative position of these nuts with respect to this assembly. Now think about this washer. It communicates how the assembly may be put together, taken part in reality. These are the washers which are kept away from its original position, but here care should be taken that they should be moved in only one direction. An actual movement in single direction only is allowed, failing to which the representation may be misleading. Suppose these all 6 nuts are selected and they are moved actually from this center to this distance. This distance may be taken as any convenient distance as per the need of the drawing and size of the drawing. Now again these washers are disassembled and exploded from these nuts. Now think about this plate. So let me select that plate, click here, and this plate is selected and this is moved horizontally in this direction. So this shows the exploded view of this component. Similarly on this side also this plate could be moved at certain distance. That distance varies as per the need of the drawing. Now think about this 6 nuts and bolts assembly. Select all these nuts and bolts, click here, selection of 1, 2, 3, 4, 5 and 6. 6 nuts are selected, and on this side also all these 6 nuts are selected. Click over here and they could move from its original position to some other distance in axial direction. So these nuts are moved from here to here, and this shows the exploded view of all these components. In this exploded view, the relative position of each components are represented. Now we pick up, annotate each components, again assembled them like this. So we can redo all these processes. Again they are assembled, disassembled, exploded, these 2 plates and these 6 nuts and bolt. This animation would show us the easy understanding of this assembly. It run through the collapse. It could be looped. Once the animation finishes, it will reset and play over again. This repeats until manually it is stopped. So it is made in the loop. If we click here paused, then only it will stop like this. Otherwise if we play, then it will go on continuously. So that is the use of solid edge to draw such an exploded view. Now this may be recorded or saved as a movie file for reply on master on most standard media type. This work can be played like this, assembled together, and we can prepare movie or video clip of this movement as well, which this facility is available in this SolidWorks as well, like this. We may stop at any instant and it will give again original position. We can save this animation like this. You can name anyone with the standard forms, say save as. So if you put here save, then whatever work we have done over here, that would be saved as a file, as a movie file, and then we can recall that movie file anywhere and it could be used for further reference or for the communication to the customer as well. The animation will start playing through slowly. Once you have recorded as much as you need, press the stop button. So with this command we can increase or reduce the speed of assembly. We can alter this movement as well with this command like this. So this movement could be varied. Here it is, the speed is reduced, the steps are changed. The movement of these steps in terms of seconds could be varied, and in some cases it could also be used in microsecond or in 10 microseconds or 0.01 seconds would be the accuracy of this movement. Here the assembly that is of 4 seconds, 8 seconds that we have prepared. So for these 8 seconds it will show here the reverse countdown, say 2.7, 2.1, 2, 1.7, 1.6 and so on, and up to 0 it will show total disassembly of this assembled component and exploded view as what we have designed and we have prepared in our presentation or in our work. What we have recorded, that will be seen over here. Now this could be seen as a preview. This one, click here, add to the window media player or open with any window media player. Almost all the extensions are supported over here. So this is the media file which we have prepared. Right? It shows all assembly of the and exploded views of this component. So I hope it's clear. Now next, adding tracking sketch lines to assist the communication of the exploded assembly configuration lines may be added to show the links between the parts. Here how to represent the links between the parts, which could be done with this command. Select two features to connect. For example, we select these features, this one, and for example bolt shoulder and the hole are selected as the features. So these two features are selected to represent the linear movement between this detailed component and assembled component. So let me select this one. Similarly on this side also, shoulder of this nut and this hole are selected over here. This hole, select that. These two holes are collinear to restrict the movement. These two holes are also made collinear, and this side also, this nut as we have selected with this washer inner surface are made collinear, and this surface, this one, select that surface. Now all these points are selected, and this axis of this hole and axis of the hole are same axis, both are coaxial, so it needs to be restricts over here. It aligns this hole and this nut and bolt. Here also to align this nut and this washer with this axis. Here this alignment is needed, so there should be coaxial. Done. Okay. Now this washer inner surface align with this, so they are, so now these all points are selected to reduce. Once all these lines are required to be added, close the root line. This root line is closed, so we have closed all these 3 lines. Animate colleagues, so all these are assembled together just with the one line as we have prepared. So it would be much faster and easier way to represent the exploded view of the component. So this is an exploded view. Now end of exercise, this one which we have done over here, exploded view of this component. Now assembly drawing may contain some other details, one or more views including section lines or auxiliaries, enlarged views to show small details in assembly drawing, this may be there. Then overall or specific dimensions needed for assembly, notes on manufacturing processes required for the assembly could be there in the assembly drawing. Balloons to indicate item numbers which are used in assembly drawing as well. And the part list, or it is also called as the bill of material, which is represented in the assembly drawing. Now assembly of screw jack. In numerous of examinations, the assembly of screw jack is asked in the subject of mechanical drafting, and students fail to draw assembly because they do not know how the relative position of each components are there in screw jack. So first you have to understand what is the screw jack, how it is assembled together, and how all the parts are with relative to each other assembled together. Then only you will be able to easily draw the assembly of screw jack. As we know, screw jack is used to lift heavy loads, particularly in automobiles. In vehicles we use the screw jack to lift the vehicle. Here we have considered mechanical screw jack.
Hi friends, this is Mohammed Shakil here, and in this tutorial I'm going to show you how you can design a screw jack in CATIA V5. On the right side you can see the completed design of the screw jack, all of the parts assembled together, and on the left side you can see the different parts and the different dimension drawings which are required to complete the screw jack design. So in my last part of the tutorial I was designing the